How minerals bond. Audioblog. It's by no means imperative to understand bonding when it comes to collecting minerals, but let's just say it helps. So here we go. First of all, ionic bonding, which we could casually refer to as a heist. This is arguably the most common type of bonding in minerals. It happens when one atom hands over an electron, or several, to another, resulting in a positive ion, known as a cation, and a negative ion, known as an anion. These cling to each other via electrostatic attraction. Think of it as an electron custody battle that ends in shared parenting via force. A classic example is going to be something like halite, NaCl, better known as rock salt. Sodium gives up an electron, chlorine takes it, boom, they stick together. Ionic bonds are responsible for the characteristic cleavage and brittleness of various minerals like halite and fluorite. They're strong, but not unbreakable. Apply enough force and they'll part like an acrimonious divorce. The second is covalent bonding, which could be casually described as sharing. Rather than one atom handing over an electron, covalent bonds involve atoms sharing electrons between each other. The result is often something extremely strong and directional. Think of it as atoms pinky swearing not to let go. A classic example is going to be diamond, pure carbon. Each carbon atom forms 4 covalent bonds with its neighbors, creating a rigid, three-dimensional lattice that's as tough as it gets. This is why diamond tops the Mohs scale. Covalent bonding is responsible for the extreme hardness and stability of minerals like quartz and corundum as well. Then we have metallic bonding. This is casually referred to as, by me, an electron party. In metallic bonds, electrons aren't tied to any one atom. Instead, they drift freely between positively charged metal ions, like party guests, hence my description. This electron sea allows metals to conduct electricity, bend without breaking, and reflect light a bit like a mirror. Classic examples are going to be things like native copper. Metallic bonding is the reason copper is malleable, ductile, and conducts electricity so efficiently. Gold, silver, and platinum behave in much the same way. And then there's the van der Waals force. Weak, but in some situations necessary. Now, this one on occasion isn't even considered a serious force, but I'm going to include it because it exists. Now, these are not true chemical bonds in the traditional sense, but rather weak electrostatic attractions between molecules or layers. They are the polite nod across a crowded room, not a hug, but an acknowledgement of presence. Classic examples, graphite. While each layer of graphite has a strong covalent bond, the layers themselves are only held together by the van der Waals force. This is why graphite flakes so easily. It's structurally a deck of cards with no elastic band. Then we have hydrogen bonding, which is kind of the underdog. Hydrogen bonding sits somewhere between covalent and the van der Waals force in terms of strength. It's a dipole-dipole interaction between a hydrogen atom, which is already covalently bonded to something else, and a nearby electronegative atom like oxygen or fluorine. Classic examples are going to be things like ice. Whilst not a mineral in the strict geological sense, unless it's in a space on top of a mountaintop, ice structures depend heavily on hydrogen bonding. Some hydrated minerals like gypsum also show internal hydrogen bonding between water molecules and other ions, influencing things like cleavage and solubility. Now, this matters because a bond determines a mineral's structure. It decides how it breaks, how it shines, how it behaves under a flame, how it reacts to water, and even how it weathers over time. Ionic minerals tend to have excellent cleavage but are prone to dissolve. Covalent minerals are hard but might shatter like glass. Metallic minerals shine and bend. Van der Waals minerals crumble. Hydrogen bonds create symmetry and peculiarities in habit. I get this isn't the most exciting aspect of minerals, but I always find it helps. It helped me a great deal once I wrapped my head around it.